are parallel? Well, it's rather easy. The aim is to simplify your vector to its lowest form by trying to pull out a constant from within brackets. So for example, in this first vector OP, you can see that 3 and -2 do not share any common factors. So it seems to be reduced as simple as possible already. And let's look at QR. So a common factor between 6 and -4 is 2. So if we were to pull out that common factor 2 in brackets by a process of division, we would be left with 3 and -2, such that if we were to expand again, you would get 2 multiplied by 3 as well as 2 multiplied by -4. That gives us back our original vector. So after simplifying our vector, one thing you would observe is that both our vectors that are contained within the brackets are exactly the same. This is how we find or determine if two vectors are parallel. We can simply reduce very large vectors, and if the vectors can be written as scalar multiples of each other, then they are said to be parallel. Let me do another example. Okay, so example 2. Let's just say we had a vector OT, and that was equal to, let's just say 6 and 9. And then we had a second vector SR, and that was equal to, let's just say, I want to choose a large number here, 12 and 15. Let's try and see what will happen here. So notice in both cases, we have vectors which can be simplified. So let's try and see what happens. So the first common factor I'll pull out from the vector OT is 3. And I'll end up getting 2 and 3 remaining within bracket. And 2 and 3 can't be simplified any further. There are no common factors. So I'll move on to my vector SR. So let me try to pull out a common factor between 12 and 15. Let's pull out 3. So if we were to pull out 3, we'd end up getting 4 and 5. Now, notice that after carefully factorizing, what's contained inside our brackets are not the same. Therefore, in this case, even after simplifying our vectors to the lowest form, we have found that the vector OT is not parallel to the vector SR. So for two vectors to be parallel, they must definitely have a commonality within those brackets, which is the vector part, and written outside, these values, they are just scalar products or scalar multiples of that vector outside, and those numbers can vary. They can be different. It would not affect the vector being parallel. So I hope that clears up any issues you guys may have with.
So I just want to pause there, right? Now, in one of the questions that we have in the 2023, CXC brought a question and they said that they wanted a parallel vector parallel 2, 5, negative 1. Now we see that for parallel vectors, the numbers contained in the bracket must be the same. So for example, to get a vector that is parallel to OT, we could simply have 4, open bracket, 2, 3. We could have negative 5, open bracket, negative 2, 3. We could have a quarter, open bracket, 2, 3. So whatever is contained in the bracket must be identical for the two vectors to be parallel. The number on the outside could be anything. And that is one concept that we need to remember. So we're going to collinearity, and then we're going to look at the past paper questions.
With vectors being parallel or not. So we are going to take some of this concept and we are going to move forward into yet another concept of vectors called collinearity. Now, for those of you who've ever heard the word collinearity before, it typically means lying on the same line. For example, if I were to draw on screen here a straight line, and on that straight line, I were to highlight 3 points, and I were to call my points O, A, and B, you can clearly see that those 3 points lie on the same line. Now, what if I were to break up these vectors that lie on this line? For example, on this line, if I were to place arrows here and here, that would mean we have the vector OA, as well as we also have the vector AB. Now, let's just say that the vector OA was equal to 1, 2. And the vector AB had values 2, 4. Now, if I were to ask you, are the vectors OA and AB parallel to each other? Well, then we can go ahead and test it. We can see that the vector OA, which is equal to 1, 2, has been reduced as much as possible. So let's try to reduce the vector AB. We can factor out 2 such that we get 1, 2. And within brackets, you can see we have ended up getting the same thing. Therefore, we can safely say that the vector OA is definitely parallel to the vector AB. Now, if two lines are essentially parallel to each other, and you were to draw them on a diagram, then they should look like this. If OA is a vector and it's parallel to another vector, AB, then if you had to represent it on a diagram, it should essentially look like this. But you see, there's a problem. These two vectors contain a letter in common. Can you identify the letter that's in common? That's correct. These both vectors contain the letter A. Now, if they both contain the letter A, how is it possible that these lines are not joined? You see, for collinearity to take place, it means that whenever two vectors are parallel to each other, but they contain a letter that's in common to both lines, then the only possible way for us to draw this information on a diagram would be by representing these 3 points on one straight line. That way, the vectors are definitely parallel to each other. As you can see, all lines that lie on the same line, or all segments of a line rather, they would be parallel to each other. They follow the same direction, the same inclination, as well as if they must contain a common letter or a common part, then they should belong to the same line. So collinearity only takes place if two conditions are met. The first condition for collinearity to happen must be that the two vectors you are considering happen to be parallel to each other. So I'll write that down. The two conditions for collinearity are that the vectors you are considering must be parallel to each other, and the second condition is that those two vectors must contain a common letter. That tells us that they all lie on the same straight line.
So we're going straight into the past papers, and I was just introduce vectors and two things and two concepts that you need to be familiar with: parallel and collinear. Now, just as we were doing over the Easter vacation, I did prepare a note for you all, and in today's group chat, I did update question 9 and 10 for you, right? I know the exam is on Friday, so you all have the notes and you have the recordings. If you all choose to do other past papers as well, I could actually send you the link so you can go and check it, right? But in today's class, we're going to do vectors and matrices. Now, we're going to start off with this question. So this is the May-June 2023. And the following vectors are defined by, so they give us Wx, Xy, and Zy. They are asking for a vector other than 5, -1 that is parallel. So remember, I told you for two vectors to be parallel, they must have a commonality. That is what we saw in the video. The commonality must be the whatever is contained in the bracket. So you could put any number on the outside, you can multiply it, and you'll be able to get the answer. So we could put 5, 5, -1, and the vector we could write is 25, -5. Or we could put -2, 5, -1, and this answer will be -10, 2. So just remember, for parallel vectors, whatever is contained in the bracket must be the same. Now, what I am interested is to find vector Wy. Now, if you notice, Wy is connected to X. So they didn't give you the vector, they give you as Wx and Y, Xy. So we're going to draw a diagram. So in my diagram here, I'm going to label W, X, and Y. So I want Wy. So write for me which two vectors you're going to use to get Wy. And remember, if the vector is traveling in the same direction, it is the same. If you're going in a reverse direction, the vector is going to be negative. So I've given you a minute or two to work out Wy. And we're using the triangular law of vectors. Now look at the marking scheme, right? This is one mark, this is one mark. So that means the level of difficulty shouldn't be too bad at all because it's just 1 mark. So what you're supposed to have, your starting point is W. So you will go from W to X, and then you will go from X to Y. Remember, this is my start, and this is my end, and this has to be the same. So we will get 5, -1, plus -3, 7. So 5 minus 3 is 2, and -1 plus 7 is the same as 7 minus 1, which is 6. So we were supposed to do that. Now, looking at the marking scheme for part 2 and part 3 is 2 marks compared to part 2, which is 1 mark. So that tells me that it is not as straightforward as part 2. So I know that X, Z, and it is connected with Y. So I'm going to draw the same diagram. And X, Y, Z. This is the vector that I want. So the 2 vectors that I need is XY and YZ. Now I recognize that they gave me ZY and they didn't give me YZ. So YZ is really -8, -7. So that tells me why it is 2 marks and not 1. Because I supposed to know to go from Y to Z, it is the opposite vector. So go ahead. Right? So we have -3, 7. Oh, I should write it. It is XY plus YZ. So -3, 7 plus, and if I find this will be -8, 7. So the final answer will be -11, 14. So you understand why CXC is given 2 marks for this, whereas the part before is 1 mark, right? So remember, if vectors are traveling in the opposite direction, the sign must change. So +8 becomes negative, and -7 becomes +7. The last part, we want to find the magnitude of XY. So the vector XY is -3, 7, but you're supposed to know what is the magnitude of the vector. And this is worth 2 marks. 2 marks, why? Because it is an application-based question. Application-based meaning that to find the mod of XY, students are supposed to know it is the square root of X squared plus Y squared, right? So once you know that, you are supposed to be able to work it out. So that is why it's 2 marks. So the vector XY is -3, 7. So work it out. This is square root of 58. So it's 7.61 units. All right, so to be honest with you, this part of the vector question that CXC brought in 2023 wasn't bad at all. And it is a part of a question that we could score full marks. There wasn't anything difficult. The only thing is, I think they would have caught students with writing a vector that is parallel. They have to understand the concept to write a vector that is parallel, but everything else was straightforward. So we go into the 2024, and they brought this diagram. Now, whatever diagram they bring in on Friday, please don't be intimidated by it. Sometimes it is more straightforward than you think. This is taken from May, June 2024, and the question reads, in a pentagon, what is a pentagon? The prefix pent means 5 sides. So it is just a plane shape with 5 sides. O, A, C, D, C, B, C, D. OA is parallel to CD, right? And OD is 2 times AB. Now, as I am reading the question, I want to put in the information that is given. AB is given the vector B. So therefore, OD is equal to 2AB. So OD is really 2B. So I just want to write that. They also go on to say that OA is 2DC. So let me think about that. So OA is 2DC, and I know that DC is half of OA. So therefore, OA is 2DC. So DC is really a half A. And as I am able to write that, it makes my understanding of the question a little bit better. So I'm able to put in values for some of the missing sides. So the vector that I want to find is AD. And you see AD now, I have all the information. So to go from A to D, I will go from A to O and from O to D. But remember that I said, if we are traveling in the opposite direction, the sign of the vector must change. So go ahead, you work it out. You could also do BC, because you could go in the direction of all these vectors and find BC. So you could do that one as well. It doesn't have to be triangular as long as it follows a pattern. So you could go ahead and find AD and find BC. BC would be BA plus AO plus OD plus DC. And you recognize the level of difficulty, right? Because the first part, you only had to work out 2 lengths there. So that's 1 mark compared to the second part, which is 2 marks. So we have AO, which is negative A plus 2B. And remember to put your answer on the line, right? And you could go ahead and find BC. So we have B minus A plus 2B plus a half A. So the next step is to group all the common terms. So you have so we're going from B to A. So that would be negative B. So we have 2B minus B is 1B. And if I have minus A plus a half A will give me negative a half A. So I do hope that you was able to get that. And remember, vectors traveling in opposite directions are called opposite vectors and the sign must change. So we would have scored 2 and 1, 3 marks. State the conclusion about AD and BC that can be drawn from your responses. So AD, so I could write this as 2B minus A. So this is 2B minus A, and BC is equal to B minus a half A. So I can look at that, right? And I should be able to pull out the common factor, right? So BC, if I take a half of this will be 2B minus A. So therefore, BC is parallel to AD. Remember, whatever is contained within the bracket, once it is the same, the vectors are parallel. Or you can say that they are scalar multiples of each other. Remember, when they ask about conclusion, what they're really asking is, you can also find the length of the vectors. They're asking if it's parallel, you can find the length, you can say it's collinear based on the information that you have, right? They also want us to find the length AD. So let me find that. So this is square root of negative 1 squared plus 2 squared. And then we have BC, which is negative a half squared plus 1 squared. So go ahead and find that. So this is square root of 5, and this is 1.25. So find it. The square root of 5 is 2.2. The square root of 1.25 is 1.1. So we could say the length AD is 2 times the length BC. Right? Because actually that is what they want you to say. And from that, you could say that BC is parallel to AD and is only 1 mark, right? So whatever you put in the answer, make sure that it pertains to the question that is being asked. All right. So we did the 2023, we did the 2024. So we go to the 2022 and then the 2021. So sometimes they bring a diagram where it's open and we need to figure it out. So whatever it is they bring, we need to be able to understand it. So as I mentioned before, when you start the question, you try and label as you go along. So in the diagram, O is the origin, OX is U, so we have that. OY is V, so we have that. OX and OY are extended such that it is a midpoint. So if it is a midpoint, therefore here must be U and here must be V. So therefore I could say that OA is 2U. You see, I get that right off the clock because I'm writing it in as I'm going. So OB is equal to 2V. And I know somewhere or the other, they're going to ask me to find something. And look, they want me to find BX. So I already have all the information, you go and find it. And remember, if it's opposite vectors, the sign has to change it. So you find BX. B is the starting point, X is the end point. All right, so we're going from B to O and O to X. So I know that OB is 2V, so BO is simply negative 2V. And OX is U. So it is U minus 2V. Somebody might ask, Miss, if I put negative 2V plus U, would I get it correct? Yes, the answer is yes. So this is 1 mark, right? It wasn't too difficult. And just by understanding what the vectors represent, we're supposed to be able to get that. And please don't be intimidated if you get a diagram that looks a little bit scary. It was open. Let me try and understand exactly what they're asking. We want, given that YA and BX intersect at M, and BM is 2MX. Express BM in terms of U and V. So it's 1 mark again, right? So let me try and find it. So we know that the line YA and BX intersect at M. So, and YX intersect at M, right? So we have that, the diagram looking good. They said that BM, B to M is 2 times M to X. Well, we could see that because look at the length here. They're saying that this is 2 times this. And they are asking you to find the vector BM. So we want to find BM. So to find BM, we need to find the vector BX. But we already have the vector bx. And they told us in the ratio 2 to 1. So if it's the ratio 2 to 1, therefore, this would represent 2/3, and this is 1/3. So remember, it's 1 marker, so that means that it's not too difficult for us to work out, and part was given in the part before. So BM is really 2/3 BX, and BX was found in the part before, right? So let me go through that again in case it was a mouthful and I lost you somewhere. What they told us in the question is that, I'll take all this. This is the line that we had originally, right? Then they said that this line meets the other line at M. You are required to find this vector. But if you notice, that vector is part of this line. They also went on to say that this is 2 parts and this is 1. So therefore, it is split into 3 parts. So this is 2/3. So 2/3 of BX. So BM is 2/3 of BX. So I want you to multiply 2/3 by everything in the bracket here. U minus 2V, and write it. Go ahead. Just multiply everything in the bracket by 2/3. So you're supposed to get 2/3 U minus 4/3 V for 1 mark. Now, if you look at the level of difficulty here, this is 3 marks. So that is what the bulk of the vector question, right? Using a vector method, show that the ratio of ym to ya is 1 to 3. Ym to ya is 1 to 3. So ym to ya is 1 to 3. So we have to find the vector ya. That is part of it. So although it's 3 marks, that doesn't mean that if you don't work it out, you're not going to get any marks. It is worth 3 marks because you have to find different parts to work on the question. So the first vector we're going to find is YE. And YE is really YO plus OA. So let's find that first. So the vector YA is YO, we have that, plus OA. So go ahead and find YO for me. YE. YE. YO plus OA. Everything is there in the diagram. All right, so this is going to give me YO is negative V plus U plus U plus U. So YA is really 2u minus v, right? Now, the next part, we already have YA, we had to find YM. Now, to find YM, we could go in this direction. We could go from Y to B and from B to M. Remember in the previous part, we found the vector BM, so we had to use that. So Y to B plus BM. So that we work out that. Y to B is the vector V plus 2/3 U minus 4/3 V. So go ahead and simplify that. So if you notice YA, so YM is 2U minus V, so 1/3 2U minus V. So this is really 1/3, right? Which is, I should write it in the opposite direction. So YM the half first. So YM, so YA is 1/3 of 2U minus V, and this is 2U minus V. So this is 1/3. So 1, so this is 1 to 3, and this has been proven. But what I'm saying to you is that although it was 3 marks, you could have scored at least 2 out of the marks if you wasn't able to follow through and do the whole thing. You're supposed to be able to follow through and get at least 2 out of the 3 marks. So we have one more. Let me wrap it up quickly and go to the matrices. So the last one we're going to do is the 2021. So you see how the vectors question could come in a variety of forms with these 4 questions that we did here tonight, right? So we have a diagram that shows a triangle OAB. OA is R, so we have that. OB is S, so we have that. So I could write it. OA is given as R and OB is given as S. In addition, E is the midpoint. E is the midpoint of CD, all right? And OD, OC is 3/4 OE. So we know that this is 3/4 here, and this is 1/4, right? Then they're asking us to AD is 2/3, and here is 1/3. I'll give you 2 minutes, find CD and OE. All right, so we're going CD. So we have all the information there, CD. So this is the little triangle here, CA, and then AD, and I have all the ratios there for you. So CD is equal to a quarter of R plus 2/3 of 2/3 of AB, but I don't have the vector AB. So now I have to go and find it. So this is 2 marks. So AB is the vector AO plus OB. So AO plus OB. So AO would be negative R plus S. So a quarter R plus 2/3 by negative R plus S. So a quarter R minus 2/3 R plus 2/3 S. So don't get confused with that, eh? Just know that you can use the calculator and work out the fractions. So this is negative 5/12 R plus 2/3 S. And everything was given there. Then we want to go from O to E. So watch where OE is. They already give us, we already find CD. So to go from O to E, we could go from O to C and then from C to E. So O to C is 3/4 R. That's straightforward. And what did they tell us about CE? It is the midpoint. So it is a half minus 5/12 R plus 2/3 S. The most difficult and challenging part of this whole question was just to use the distributive law and multiply it out. So multiply it out and simplify the answer for me. Right? So you will get 3/4 R and a half multiplied by 5/12 is minus 5/24 R plus a half multiplied by 2/3, 1/3 S. So 3/4 minus 5/24 will give us 13/24 R plus 1/3 S. So the most difficult part of this whole thing was just to multiply it out. The next part, we want OR written as a column vector. So you could get it as a row. So OR, or the vector R, is negative 1, 4. To take that as a row and write it as a column will be negative 1, 4. And the last part of this question was to find QR. So we want to find the vector QR, and QR has coordinates 5, 2. So we want to find QR. So to go from Q to R, we could go from Q to O and then O to R. So Q is the vector here, 5, 2, and we want to go from Q to R. So let me work it out. QR will be QO plus OR, and so this will be negative 5, negative 2, and OR is the vector negative 1, 4, I believe, here. So work out that and then find the mod of QR. Go ahead. and the square root of 40 is 6.32 units. All right. So we're going straight into the matrices. So we want to work out the product. And remember how we multiply matrices? We multiply row by column. So this is worth 2 marks. So we multiply row by column, row by column, row by column. So this is a 2 by 2. This is a 2 by 3. So our final answer must have 2 rows and 3 columns. So it is somewhat identical to this one. All right, so I'll give you some time to work it out. So remember, it's row 1, column 1, then column 2, then column 3. So row 1, column 1, row 1, column 2, row 1, column 3. Then we go to row 2. Row 2, column 1, row 2, column 2, and row 2, column 3. Row 3, column 3. Row 2, column 3. Then the different colors. So you get a chance to work it out. So 5, first element with first element, second element with second element. So 5 by 2 is 10 plus 0. Then 5 by 1, 4 by 3. So that is 5 plus 12. Then 5 by negative 4, 4 by 6. So that is negative 20 plus 24. All right. So we have the second one now, the second row. So negative 3 by 2 is negative 6 plus 0. Negative 3 by 1 is negative 3 plus negative 6. Then we have 12 minus 12. Simplifying my 2 by 3 matrix, I will get 10, 17, 4, negative 6, negative 9, and 0. Right? State why 2 matrices are conformable for multiplication. So for AB to be conformable, the number of columns of matrix A must be equal to the number of rows of the first. So we could say 2 matrices are conformable if the number of rows columns of the first is equal to the number of rows of the second, anything like that. We want the inverse. So to find the inverse of this, we must find the determinant. So 5, 4, -3, -2. So to find the determinant, we cross the diagonals. So it is 5 by -2, take away 4 by -3. And then we have, this is the determinant. We have the adjoint, which is, we swap places for the leading diagonal. So it becomes -2, 5. And for the second diagonal, -4, 3. So work out the inverse. 1 over the determinant by the adjoint. Work it out. All right, so we get -10 plus 12. This is 2. So it's 1 over 2, -2, -4, 3, 5. So you multiply it out and you will get -1, -2, 3 over 2, and 5 over 2 for 2 marks. All right, so that concludes that part of the question. So that was the 2020 D1. Let us go to, we don't do that yet. Right. I'll leave any transformational matrices for us. All right, so we want the determinant of this matrix and we want to find the value of V. So we know how to find the determinant. We cross the diagonals. So this is 6, 2V minus 5 minus V. So the determinant will be -6 multiplied by -V, take away 2V multiplied by -5. And this is equal to 24. So go ahead and put it equal and find the value of V. So it's straightforward, 2 marks. Go ahead. All right, so we have 4v is equal to 24. V is 24 divided by 4. V is equal to 6. So that wasn't bad at all for 2 marks, right? We want the matrix product LM. So remember, before you start multiplying, you need to know what kind of matrix you will get. This is a 2 by 2, and this is a 2 by 1. So the resultant will be a 2 by 1. So go ahead and multiply. All right, so let me see. So remember, row by column, right? So 9 by 2, 18, plus negative 20, and 3 twos are 6 minus 8. So the matrix product here is negative 2, negative 2. And to be honest with you, that wasn't bad for 2 marks, 2 marks. We want the inverse of L. All right, so I write in the matrix L here, you find the inverse. 9, 5, 3, 2. So go ahead and find the determinant of L, then find the adjoint of L. Go ahead. So 18 minus 15, this is 3. Here we will get 2, 9, -5, -3. Now is for 2 marks, right? So just make sure that you're getting 2 marks. So it's 1/3 by 2, -5, -3, and 9. So don't leave it just so, multiply it out. So you get 2/3, -5 over 3, -1, and 3. I don't know exactly what you're looking for, right? But you try and multiply it out. Now, we have a part here. We have PQ, and we want the coordinates of Q, so we go work it out. Using the vector rule, PQ is the vector PO plus OQ, right? And we want to find the vector OQ. So we could take PQ and we could subtract the vector P, and we should be able to get the answer. So this is 5, -4, and this would be negative of -2, 3, which will give us +2 and -3, plus OQ. So OQ is the vector 5 minus 2, if you carry it across, and -4 plus 3. So this will give you 3, -1. You can check it back. All right, so we reached the final part here, which is the transformational matrices. So I want to point out something. Now, this is my note here. There are certain transformational matrices that you need to know. R is 90, reflection in the x-axis, reflection in the y-axis, reflection in the line y equal to x, reflection in the line y equal to -x. So make sure you learn that. So let me see what CXC brought here. The transformation matrix A represents a rotation of 90 degrees anti-clockwise about the origin, right? And then write the coordinates of the image P prime, the image of the point 7, 11, after it undergoes a transformation about a 90 degrees. So for 1 mark, so we want P prime. So you're taking the rotation of 90 degrees. So let me show you something. If you put 0, -1, 1, 0, and you put the 7, 11 here, this is a 2 by 1, and this is a 2 by 2. You're supposed to know that this can't work. So therefore, the matrix 7, 11 have to come to the right. This is a 2 by 2, and this is a 2 by 1. So this is the same. So the matrix you're going to get here is 2 by 1. So multiply it row by column, and then row by column. Go ahead. Right? So here we will get 0 by 7 is 0, -1 by 11, -11, 1 by 7 is 7. So here we will get -11, 7, right? -11, 7 for 1 mark. But if you notice, they ask for the coordinates. So then I want you to write it like this. You write it -11, 7. CXC very particular about what they ask, right? So they want coordinates, so write it as a coordinate. T is the combined matrix of A followed by B. Now, that is no way AB. They say T is the combined matrix of A. So A going first. So this is really BA. Now, both are 2 by 2 matrix. So you don't know, you can't be able to tell whether it's AB or BA. So this is something that you need to know. So the transformation matrix is BA. So we take in 0, -1, -1, 0, and you're multiplying it 0, -1, 1, 0. So multiply it and see what you get for 2 marks. Row by column by column. So then -1, 0, -0, 1. So 2 marks, that is what we would have gotten. Then they are asking to describe geometrically the transformation represented by T. So this is where you're supposed to learn some of the transformational matrices. So what we're looking for is which matrix is -1, 0, 0, 1. So we're going back to the table. -1, 0, 0, 1. So we're looking for -1, 0, 0, 1. And this is a reflection in the y-axis. -1, 0, 0, 1. The reflection in the x is 1, 0, 0, -1. Right? So this is one that they're asking about, and I feel it is a popular one because in the next question that we're going to do, you will see they're asking the same thing. So this is a reflection. T is a reflection in the y-axis. And the last part here, determine the value of K so that matrix C is singular. A matrix is singular if the determinant is 0. So go ahead, find the determinant, put it equal to 0, and find K. So it's 4 by 3, subtract K by 6. So 12 minus 6K is 0. So this means 6K is 12, K is 2. And that I think that is 2 marks, right? So we do it anything that they could bring, any and everything. All right, so this is the last one. The matrices AB represented by the transformation are given above. Determine the elements of matrix C, which is an anti-clockwise rotation of 90 degrees followed by. So they're asking for the rotation first, followed by. So let me see, work it out. So we write in 0 minus 110. This is the 90 degrees, followed by this one coming in front, which is 0, -1, -1, 0. So it's BA again. Look at that. So they say the 90 degrees rotation, put that first and put it followed by in front. And you're multiplying row by column by column. Go ahead. So you get -1, then 0 by -1, you get 0 there. Then here you get -1, 0, 0, 0, 0. Then you get +1. So we have the same matrix, right? Which is -1, 0, 0, 1. And this is a reflection in the y-axis. So that seems to be a popular one. Okay. All right. So here you're writing it. All right. And they say that a transformation T, we want to determine the value of K. So 1, 2, K -1 multiplied by the matrix, the 2, 1 will give you 8, 15. So you have to multiply it and you'll find K. So let me show you how easy this is. This by this will give you 8. So you have no reason to do that. So just multiply this by this, put it equal to 15, and you'll get the answer. So multiply this by this and put it equal to 15. So you'll get so 2K minus 3 is equal to 15. 2K is equal to 15 plus 3. 2K is equal to, look it up. K is equal to 9.